Welcome back, dear student. I hope the last session or last topic has been helpful or understood by you all. We are into the next topic. Let's check it out. What is next topic for today? Today's topic is equation of motion by graphical method. The motion of a body moving with uniform acceleration can be described with the help of three equations called equation of motion. That equation of motion we have already read, that first is v is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. Click each tab to know more about it. Equation for velocity time relation, that is v is equal to u plus at. Consider a velocity time graph for a body moving with uniform acceleration a. The initial velocity of body is u at a and it reaches a final velocity v at b in time t. Draw the perpendicular line BC and BE from point B to the time t and velocity axis so that the initial velocity is OA, final velocity is BC and time interval is OC. Now draw a line AD parallel to OC. We observe that BC is equal to BD plus DC is equal to BD plus OA. Substituting BC is equal to V and OA is equal to U, then we get V is equal to BD plus U. This implies BD is equal to V minus U. Acceleration is equal to change in velocity by time, as we all know. So A is equal to BD by AD is equal to BD by OC is equal to V minus U by T. This implies AT is equal to V minus U or V is equal to U plus AT. Now the second equation of motion, that is equation for position time relation, that is S is equal to ut plus half at square. Consider a velocity time graph for a body moving with uniform acceleration a, traveling a distance s in time t. The distance traveled by the object between the points A and B is the area OABC, which is a trapezium. This implies S is equal to area of OABC implies S is equal to area of rectangle OADC plus area of triangle ABD. This implies S is equal to OA into OC plus half AD into BD. Substituting OA is equal to U, OC is equal to AD is equal to T and BD is equal to V minus U is equal to AT. We get S is equal to U into T plus half T into AT. After that, will implies that S is equal to ut plus half at square. Now the third equation of motion, that is equation for position velocity relation, that is v square minus u square is equal to 2as. Consider a velocity time graph for a body moving with uniform acceleration a, traveling a distance s in time t. The distance traveled by the object between the points A and B is the area OABC, which is a trapezium. This implies S is equal to area of trapezium OABC. This implies S is equal to OA plus BC into OC by 2. Substituting OA is equal to U, BC is equal to V and OC is equal to T. We get S is equal to U plus V into T by 2. From velocity time relation, T is equal to V minus U by A. Therefore, S is equal to U plus V into V minus U by 2A. This implies V square minus U square is equal to 2AS. That is third equation of motion. Now follow-up work. Suggest few examples for motion of an object where its speeds remain constant but velocity changes. What is the displacement of the body if its return to same point where it is started. Give one example in daily life. Now we have successfully completed the chapter, that is motion.